Welcome everyone to BTT 151 Fundamentals of Electricity. I'd like to go over your Unit 11 homework. Question 1, what is the dielectric? The dielectric is the insulating material. Remember the definition of a capacitor? It's two parallel plates separated by a dielectric, that insulating material. Question 2, list three factors that determine the capacitance of a capacitor. Well, the expression for capacitance C, is equal to a constant K, which is the constant for the dielectric being used in the construction of the capacitor, multiplied by the area of the plates, divided by a numerical constant, 4.45 times D, which is the distance between the plates. So three factors that would determine the capacitance of a capacitor based on this expression would be the area of the plates, the dielectric material being used, as well as the distance between the plates. Question 4, in what form is the energy of a capacitor stored? Electrostatically. Question 5, for capacitors having values of 20 microfarad, 50 microfarad, 40 microfarad, and 60 microfarad are connected in parallel. What is the total capacitance of this circuit? For capacitors in parallel, C equivalent is equal to C1 plus C2 plus C3 plus C4. So what I like to tell students, capacitors in parallel add like resistors in series. It's the same type of expression. So all you have to do is add up 20, 50, 40, and 60, and your final answer will be 170 microfarad. Question 11, how many degrees are the current and voltage out of phase in a purely capacitive circuit? Current leads the voltage in a purely capacitive circuit by 90 degrees. Question 12, does the current in a purely capacitive circuit lead or lag the applied voltage? The current leads the applied voltage, again by 90 degrees. Question 13, a 30 microfarad capacitor is connected into a 240 volt 60 hertz circuit. What is the current flow in this circuit? So again, write down what we were given. We were given the voltage V, 240 volts. We were given the frequency 60 hertz, and we were also given the value of the capacitor, 30 microfarad. So there's an expression from Ohm's law. The current I is equal to the voltage V divided by the capacitive reactance C. So I'm simply going to plug these numbers in. Voltage is 240 in the numerator. In the denominator, 1 divided by 2 pi multiplied by the frequency of 60 multiplied by the value of the capacitor, 30 microfarad. So you do the math, and we should get a current of 2.71 amps. And the last question, question 14. A capacitor is connected into a 1250 volt 1000 hertz circuit. The current flow is 80 amps. What is the capacitance of the capacitor? So again, write down what we're given. Voltage V is 1250 volts. Frequency is 1000 hertz. And we have a current flow of 80 amps. So this time we're going to rearrange the expression. We're looking for the value of the capacitance. So doing some algebra, the value of the capacitance C is going to be equal to 1 divided by 2 pi times the frequency times the value of capacitive reactance. So to get the value of capacitive reactance, I can take the voltage divided by the current, just like we did in question 13. So 1250 divided by 80 would give us that value of capacitive reactance. Plug the other numbers into the equation. Frequency is 1000, remember. Do the math, and we should get a capacitance value of 10.17 microfarad. Thank you.